Welcome to Tech with Koushik. This is set 4 of our AI-103 Microsoft Certified AI Engineer Associate Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam-ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link is in the description. Let us begin set 4. The next item is question number 129. This question focuses on few-shot prompting. A classification application must assign support tickets to one of 4 internal categories. The base model understands the categories, but sometimes formats labels inconsistently. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, providing a small set of representative input-output examples can help demonstrate the desired category labels and output pattern. The second statement is, few-shot examples require retraining the model weights before they can influence a response. The third statement is, examples should be relevant to the intended task rather than unrelated demonstrations. Statement 1. The answer is yes. Few-shot prompting demonstrates the desired task behavior and formatting through examples placed in the prompt context. Statement 2. The answer is no. Few-shot prompting changes the input context, not the underlying model weights. Statement 3. The answer is yes. Relevant examples provide stronger guidance than examples from unrelated tasks. Use examples to teach response patterns in context. Use fine-tuning only when changing model behavior through training is justified. Question number 130 requires careful analysis. Pay close attention to every stated constraint. A report writing application produces a first draft, then needs the model to review that draft against a checklist and create a corrected version before returning the result. Which pattern best matches the requirement? Evaluate each option against the stated requirement. Next, option A, a reflection or self-critique loop. Next, option B, token usage monitoring. Next, option C, image moderation. Next, option D, a search index or schedule. The correct answer is option A, a reflection or self-critique loop. Here is the technical justification. A reflection or self-critique loop asks the model to inspect an earlier output against criteria and revise it before the final response. B. Token monitoring measures consumption but does not revise content. C. Image moderation is a visual safety feature. D. An index or schedule controls retrieval data ingestion rather than response refinement. Remember this distinction for the exam. Reflection adds a review and revise step. Monitoring observes behavior without changing the current answer. Now consider question number 131. The focus now shifts to function tool schema. Consider this scenario. An agent calls a custom function named create_service_ticket. The application needs the model to know which arguments the function accepts and which arguments must always be supplied. Which 2 pieces belong in the function tool schema? Select 2. Choose every option that satisfies the requirement. The options are: Choice A, a description of the function and when it should be used. Choice B, a parameter schema that defines argument names, types, and required fields. Choice C, the Azure subscription invoice. Choice D, a screenshot of the Foundry portal. Choice E, a model retirement notice. The required selections are option A description of the function and when it should be used, and option B, a parameter schema that defines argument names, types, and required fields. Function tools need a clear description and a structured parameter schema so the model can decide when to call the function and construct valid arguments. The incorrect choices fail for the following reasons. C. Billing information is unrelated to function argument construction. D. A portal screenshot does not define a callable tool contract. E. Model lifecycle information does not define the function interface. A useful examination rule is this. A good tool contract tells the model what the tool does and exactly what arguments it accepts. Proceed to question number 132. Review the situation. A creative application uses a supported GPT image model. Draft previews should render with lower cost and faster generation, while the final approved asset should prioritize visual quality. Select the appropriate quality setting for each stage. Choose the correct entry for every drop-down field. Statement 1. For inexpensive draft previews, use the blank. Choose between 1. Low, high, or transparent. Statement 2. For the final asset when quality is the priority, use the blank. Choose between 2. High, low, or text. For statement 1, select low. Low quality reduces generation effort for preview iterations. For statement 2, select high. High quality is appropriate when the final visual result matters more than generation cost or speed. The key takeaway is use lower quality for iteration and higher quality for final assets when the model supports those controls. Let us examine question number 133. We are moving to multi-image reasoning. Let us first review the situation. An insurance application receives 2 photographs of the same vehicle, one taken before repair and one after repair. The user asks the model to explain the visible differences between the 2 images. Which approach is most appropriate? Review each available choice. Option A is send both images and the comparison question to a vision-capable multimodal model. Option B is run text-only sentiment analysis on the file names. Option C is generate a new vehicle image and compare it with one source photograph. Option D is use text-to-speech to describe the repair. The best answer is option A. Send both images and the comparison question to a vision-capable multimodal model. The key reason is a vision-capable multimodal model can accept multiple images in context and reason about visual differences in response to a natural language question. The other choices do not satisfy the requirement because B. Sentiment analysis cannot compare visual evidence. C. Generating a new image introduces synthetic evidence and does not compare the 2 originals. D. Text-to-speech produces audio and does not analyze images. Keep this examination point in mind. When reasoning depends on relationships across multiple images, provide the images together to a multimodal model. We will now analyze question number 134. Consider the following scenario. A digital library application needs different levels of descriptive text for uploaded photographs. Match each requirement to the most suitable output. Review the available source items. Source 1. A short description suitable for a compact gallery card. Source 2. A richer accessibility description that includes more visual context. Source 3. An answer to the question, how many people are standing near the entrance? The target positions are: Target A, concise image caption. Target B, extended image description. Target C, visual question answering. Target D, image generation. Map a short description suitable for a compact gallery card to concise image caption. Map a richer accessibility description that includes more visual context to extended image description. Map an answer to the question, how many people are standing near the entrance, to visual question answering. The requirement is satisfied because a concise caption summarizes the image briefly, an extended description provides richer accessibility context, and visual question answering answers a specific question from image evidence. Exam tip. Choose the visual output pattern by intent, short description, detailed accessibility context, or question-specific evidence. Question number 135. This question moves us into visual field extraction. Scenario. A warehouse application receives shelf photographs and must return the same structured fields for every image: product_type, package_condition, and visible_quantity. Which approach best supports reusable structured extraction? Option A. Create a content understanding image analyzer with a schema for the required fields. Option B. Use text-to-speech for each photograph. Option C. Create an Azure AI search synonym map. Option D. Use a batch text translation job. The required response is Option A. Create a content understanding image analyzer with a schema for the required fields. The reasoning is as follows. A content understanding image analyzer can define a reusable field schema and return structured visual information consistently across many images. The alternatives can be eliminated because B. Text-to-speech generates audio and does not extract visual fields. C. A synonym map affects text query matching, not visual extraction. D. Text translation does not analyze image contents. Use a reusable image analyzer schema when the same structured visual fields must be extracted repeatedly. Question number 136. Background. A design team is creating a new campaign poster with a supported GPT image workflow. Current environment. The team has a reference image that establishes the desired product appearance, but the new poster should use a different background and composition. Business requirements. The product should remain visually recognizable while allowing the model to create a new scene. Technical requirements. The workflow should use the reference image as generation input rather than restrict editing to one masked region. Which approach should you use? Review the options. Choice A. Provide the reference image with the new prompt to a supported image generation workflow. Choice B. Use OCR on the reference image and discard the visual input. Choice C. Use only a text embedding of the campaign description. Choice D. Run image moderation and treat the moderation labels as the generated poster. The appropriate choice is option A. Provide the reference image with the new prompt to a supported image generation workflow. This is correct because supported GPT image workflows can use reference image input together with a prompt to generate a new composition while preserving important visual characteristics from the reference. Now consider why the remaining options are unsuitable. B. OCR preserves only recognized text and loses the product's visual appearance. C. Text embeddings do not generate the visual scene. D. Moderation classifies safety content and does not create images. Remember this distinction for the exam. Use reference media when the model must create a new scene while carrying visual characteristics from an existing image. The next item is question number 137. Next, we enter the topic of video understanding flow. Scenario. A training video system uses Azure Content Understanding before sending selected evidence to an LLM. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. Video segmentation can help break a long recording into meaningful sections for downstream reasoning. Statement 2. Transcript information can provide searchable spoken content from the video. Statement 3. Generating a brand new video is required before the original video can be analyzed. The answer to statement 1 is yes. Segmentation makes long audiovisual content easier to organize and reason over. The answer to statement 2 is yes. Transcripts expose the spoken content for search, grounding, and downstream analysis. The answer to statement 3 is no. Understanding workflows analyze the source media directly. Generation is not a prerequisite. A useful examination rule is this. Separate video understanding from video generation. Analysis extracts evidence from existing media. Review question number 138. Carefully. Begin by examining the scenario. A support application receives short text messages in unknown languages. It must identify the language before deciding whether translation is necessary. Complete the translator request design. The first statement reads, use the translator the blank operation to identify the source language. The options for this statement are 1. Detect, transliterate, or dictionary lookup. The second statement reads, use the return the blank value to judge the confidence of that detection. The options for this statement are 2. Score, audio duration, or vector dimension. The correct value for statement 1 is detect. Detect is specifically designed to identify the language of a text string. The correct value for statement 2 is score. The score indicates confidence in the detected language. The key takeaway is use detect to identify language. Use translate only after you know or choose the source to target language path. Proceed to question number 139. The focus now shifts to text transliteration. Review the situation. A travel application receives a city name written in Cyrillic script. The user wants the same language represented in Latin characters, not translated into a different language. Which Azure Translator operation should you use? Available choices. Option A, transliterate. Option B, translate. Option C, detect. Option D, sentiment analysis. In this case, select option A, transliterate. Here is the technical justification. Transliteration converts text from one writing system or script to another while preserving the original language rather than translating its meaning. The remaining options are incorrect because B, translation changes the language of the text rather than only its script. C, detect identifies the language but does not convert the script. D, sentiment analysis classifies opinion polarity and is unrelated to script conversion. Keep this examination point in mind. Translation changes language. Transliteration changes script. Let us work through question number 140. Review the scenario carefully. A logging pipeline stores customer chat messages. Before storage, it must identify personal information and also produce a redacted version of the text. Which two outputs or capabilities from Azure Language Text PI are directly useful? Select 2. Identify all valid responses. Compare the following options. Choice A, detected PI entities and categories. Choice B, redacted text. Choice C, a generated marketing image. Choice D, a vector search HNS graph. Choice E, a synthesized speech file. Select option A, detected PI entities and categories, and option B, redacted text. Text PI can identify predefined personally identifiable information entities and return text with detected sensitive values redacted. C. Image generation is unrelated to text PI protection. D. An HNS graph is part of vector search rather than PI processing. E. Speech synthesis produces audio and does not redact sensitive text. Exam tip. PI processing can both identify sensitive entities and provide a redacted text representation for downstream use. Now consider question number 141. A knowledge application needs 2 different summarization behaviors. Match each requirement to the appropriate summarization method. Begin with the following source items. The first source item is return important original sentences from the source text. The second source item is generate new concise sentences that express the main ideas. The third source item is summarize specifically around a user-supplied topic of interest. The destination requirements are as follows. Destination A, extractive summarization. Destination B, abstractive summarization. Destination C, query-focused summarization. Destination D, language detection. The first mapping connects return important original sentences from the source text to extractive summarization. The second mapping connects generate new concise sentences that express the main ideas to abstractive summarization. The third mapping connects summarize specifically around a user-supplied topic of interest to query-focused summarization. The key reason is extractive summarization selects source sentences, abstractive summarization generates concise summary wording, and query-focused summarization emphasizes information related to a supplied query. Extractive keeps source sentences, abstractive rewrites. Query-focused steers the summary toward a specific topic. The next key item is question number 142. Next, we enter the topic of speech phrase list. Focus on the following situation. A real-time speech-to-text application frequently misrecognizes 3 uncommon product names. The team wants a lightweight runtime improvement and does not want to train a new custom speech model. What should you configure? Focus on the distinction between these options. Now examine choice A, a phrase list containing the product names. Now examine choice B, a new image generation deployment. Now examine choice C, a search synonym map only. Now examine choice D, a video remix job. The required response is option A, a phrase list containing the product names. The requirement is satisfied because speech phrase lists boost the recognition likelihood of specified words or phrases at runtime and do not require training a custom model. The incorrect choices fail for the following reasons. B. Image generation does not affect speech recognition. C. A search synonym map changes search query matching rather than speech recognition. D. Video remix edits generated videos and is unrelated to speech to text. Remember this distinction for the exam. Use phrase lists for lightweight runtime vocabulary biasing. Use custom speech when broader domain adaptation requires training. We will now analyze question number 143. Let us first review the situation. A voice application must choose between short single utterance recognition and continuous recognition. For each statement, select yes if the statement is true. Otherwise, select no. Review statement 1. Continuous recognition is appropriate when the application must process an ongoing audio stream over multiple utterances. Review statement 2. A single-shot recognition call is always the best choice for a long live conversation. Review statement 3. Speech recognition mode should be selected based on the expected audio duration and interaction pattern. Statement 1 should be marked yes. Continuous recognition is designed for ongoing streams and multiple recognition events. Statement 2 should be marked no. A long conversation requires ongoing recognition rather than one short single utterance operation. Statement 3 should be marked yes. Choosing the correct recognition mode depends on how audio arrives and how long recognition must remain active. A useful examination rule is this. Use short recognition for bounded utterances and continuous recognition for ongoing conversational audio. Let us examine question number 144. Begin by examining the scenario. You are defining fields in an Azure AI search index. Match each requirement to the field attribute that directly enables it. The source items are as follows. Source item 1. Allow full-text queries over the field. Source item 2. Allow equality or range filtering on the field. Source item 3. Return the field value in search results. Now review the available destinations. Destination option A, searchable. Destination option B, filterable. Destination option C, retrievable. Destination option D, facetable. For mapping 1, pair allow full-text queries over the field with searchable. For mapping 2, pair allow equality or range filtering on the field with filterable. For mapping 3, pair return the field value in search results with retrievable. The reasoning is as follows. Searchable enables lexical full-text search. Filterable enables OData style filters, and retrievable controls whether field values can be returned in results. The key takeaway is searchable affects matching, filterable affects selection constraints, and retrievable affects what comes back to the client. Review question number 145. Carefully. We are moving to semantic field priority. Consider the following scenario. An Azure AI search index contains title, body, tags, and last updated fields. The team is configuring semantic ranking and wants the service to understand which fields represent the document title, natural language content, and keyword style terms. What should you configure? Choose from the following options. Choice A, a semantic configuration with prioritized title, content, and keyword fields. Choice B, a speech recognition phrase list. Choice C, an image generation mask. Choice D, a content filter block list. The correct answer is option A, a semantic configuration with prioritized title, content, and keyword fields. This is correct because a semantic configuration identifies prioritized title, content, and keyword fields used by semantic ranking, captions, highlights, and answers. The other choices do not satisfy the requirement because B, phrase lists improve speech recognition, not search ranking. C, masks are used for image editing. D, block lists are safety controls and do not identify semantic search fields. Keep this examination point in mind. Semantic ranking depends on a semantic configuration that points to the index fields containing meaningful natural language content. The next item is question number 146. Consider this scenario. A team is comparing Azure AI search vector algorithms. One workload needs fast approximate nearest neighbor retrieval over a large index. Another small validation workload needs exact nearest neighbor results for comparison. Select the appropriate algorithm for each workload. Review each blank and choose the most appropriate option. Review statement 1. For scalable approximate nearest neighbor search, use the blank. The available choices are 1. HNSW, exhaustive KNN, or semantic captions. Review statement 2. For an exact brute force nearest neighbor comparison, use the blank. The available choices are 2. Exhaustive KNN, HNSW, or keyword highlighting. The answer to the first statement is HNSW. HNSW is optimized for efficient approximate vector retrieval on larger datasets. The answer to the second statement is exhaustive KNN. Exhaustive KNN is computationally heavier, but provides exact nearest neighbor results. Exam tip. HNSW trades a small amount of recall for speed. Exhaustive KNN favors exactness over query efficiency. Evaluate question number 147. Against every requirement. Identify the decisive requirement in this scenario. ARAG ingestion pipeline splits long manuals into chunks. Important sentences sometimes cross the boundary between adjacent chunks, reducing retrieval context around those boundaries. Which text split configuration can help preserve context between successive chunks? Compare every choice before deciding. Consider option A. Set a non-zero page overlap length. Consider option B. Set every field to facetable. Consider option C. Disable all embeddings. Consider option D. Remove the document text before indexing. The best answer is option A. Set a non-zero page overlap length. Here is the technical justification. Page overlap length carries a portion of the previous chunk into the next chunk, helping preserve contextual continuity around split boundaries. The alternatives can be eliminated because B. Faceting is a search navigation feature and does not change chunk boundaries. C. Disabling embeddings does not preserve cross-chunk text context. D. Removing the text prevents useful indexing altogether. Use overlap when context can straddle chunk boundaries, but avoid excessive overlap that duplicates too much content. Now consider question number 148. An Azure AI search skill set extracts OC or text from images embedded inside a document. The downstream pipeline needs one combined text value that contains the original document text together with the OC or derived text. Which built-in skill is designed to combine those text values? The options are Choice A, merge skill. Choice B, language detection skill. Choice C, image analysis skill. Choice D, key phrase extraction skill. The appropriate choice is option A, merge skill. The merge skill combines multiple strings into a unified text value and is commonly used to merge OC or derived text with existing document content. Now consider why the remaining options are unsuitable. B. Language detection identifies the language of text, but does not merge values. C. Image analysis extracts information from images rather than combining text strings. D. Key phrase extraction identifies important phrases, but does not concatenate text. Remember this distinction for the exam. Use merge when enrichment produces text fragments that must be recombined before later skills or indexing. Next, question number 149. This question moves us into shaper skill. A skill set produces several enrichment outputs that need to be reorganized into one structured object before projection or indexing. Match each requirement to the appropriate skill set concept. The items to be placed are: Source 1. Combine multiple enrichment values into a structured complex object. Source 2. Provide the structured output to a later skill. Source 3. Map the final enrichment result into an index field. Match the source items to these destinations. Target A. Shaper skill. Target B. Skill input from the enrichment tree. Target C. Output field mapping. Target D. Vector similarity metric. The correct destination for combine multiple enrichment values into a structured complex object is shaper skill. The correct destination for provide the structured output to a later skill is skill input from the enrichment tree. The correct destination for map the final enrichment result into an index field is output field mapping. The key reason is the shaper skill creates structured output from enrichment values. Later skills can consume values from the enrichment tree, and output field mappings write final values into index fields. A useful examination rule is this. Use shaper to restructure enrichment output. Use mappings to move the final values into the search index. Question number 150. Review the situation. An Azure AI search index is populated from an Azure Blob Storage data source that changes throughout the day. The team wants new or updated content to be picked up automatically without manually starting every index or run. Which two statements describe an appropriate design? Select 2. Select all answers that apply. Review the options. Option A. Configure an indexer schedule. Option B. Use the data source's supported change detection behavior so scheduled runs can process changes incrementally. Option C. Recreate the search service before every run. Option D. Disable the indexer permanently after the first execution. Option E. Use image generation to detect changed blobs. The correct answers are Option A. Configure an indexer schedule, and Option B. Use the data source's supported change detection behavior so scheduled runs can process changes incrementally. The requirement is satisfied because scheduled indexers can run automatically at recurring intervals, and supported change detection lets the indexer process new or changed source content incrementally. The remaining options are incorrect because C. Recreating the search service is unnecessary and destructive. D. A disabled indexer cannot perform the recurring ingestion requirement. E. Image generation is unrelated to data source change detection. The key takeaway is for changing data sources, combine scheduled index or execution with supported change detection. You have completed Set 4 of the AI-103 Microsoft Certified AI Engineer Associate Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Koushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.